Hi, my name's Claire Flitcroft from the University of Sydney, and my talk is titled Playing with Lego. Did you know that building molecules is a lot like building Lego? And would you have guessed that our bodies are Lego masters? From just a limited set of 20 Lego pieces, or rather amino acids, our bodies produce over 20,000 different proteins to help control the structure, function, and regulation of our body's tissues and organs. But building Lego with only 20 different pieces can only get you so far. As a chemist, I'm fascinated by the ability to add on some new fancy Lego pieces onto these complex structures that nature has already built for us. Let's take this pyramid as an example. Each block represents an amino acid, and you can see that we're building up complexity piece by piece and level by level. But what happens if I decide to change one of these pieces for a different one? How can I do that without tearing the whole structure apart and building it up again from scratch? Well, I use a technique called photoredox catalysis. This is where I use energy in the form of visible light to change the structure of my molecule exactly where I want to, without interfering with any other part of it. To do this, I made a master Lego piece. This special piece can be put onto my molecule after it's been built. Then, simply by shining blue light on it in the presence of a metal catalyst, I activate that part of the molecule. The masterpiece falls off and a new flashy piece can slot right in. But here's where it gets really cool. From this one modified molecule, I can now swap out this master Lego piece to build hundreds of these complex molecules in just one step. This is a really quick way to generate several different versions of a molecule that can be used for drug screening. But why do I need to change these molecules in the first place? Well, put simply, we don't really know what makes a drug so effective against a disease until we test it. By developing this method, not only can we streamline the process of making these complex molecules, but we can also test molecules that could never have been built before. While our original Lego set may have only contained a handful of different pieces, over the years, we've developed so many new interesting pieces to put onto our molecule, and now we have the technology to actually do that, giving us access to a near infinite amount of potential proteins. With this new technology in hand, there really is no limit to what we can do.